Hello, back again, and we will resume from the previous tutorial. And in this tutorial, dive, we will dive, we will try to move the character along x and y axis, and that will be mapped on our that will be mapped on our arrow keys, just like in the game. That is up and down arrow for moving up and down, and similar for left and right. Similarly for left and right arrows, each arrow will take you to respective decision, take you to respective direction. So without further ado, let's get you started. Again, here I will show you I will take you to docs. I will ask you to head to docs.unity3d.com, and there you can simply type input.getAxis or input, and here you can I will show you how you can do that. Docs.unity3d. Then you need to go to scripting API. Again, these are the official docs, and it is best that if you are lost or if you are trying to do something that you are not sure of, or you want explanation for something that is already there, you head over to the documentation uh, of the certain function, and it will explain you things in much more specific, in much more better way, and uh, from much better professionals that have written this and made software available for everyone. And this is the intended way of using this software. So let's type input get input, and when you press input, you can see interface into legacy input system, and then this is the input.getAxis. Again, legacy means old, and even though it does work, for some cases we wouldn't mind to uh, again, these are all these relative sub functions that can be used, and right now we will explore input.getAxis and how you can move the object in specific direction. So without further ado, let's take a look at the script. And what has this done is created two, let's create two variables with the name speed and rotation speed. Again, this is float. You can change. Again, it's best to use float here because uh, things are in decimal points. So to get the better accurate result, it's best to use float instead of int, and then caring about how you can convert the int packs to float. So inside update, all you gotta do is copy this stuff here, and I will explain this each one here specifically. But what has this done? So let's this so to check this further, let's see what has this done. It has taken two variable speed and rotation speed. Speed is 10 and rotation speed is 100 f. So for the input axis vertical, so what are vertical axis? By default, they are mapped to arrow keys, just like I've said. Up and down. Vertical is up and down, and horizontal is left and right. So to move it, you gotta do what you gotta do is make it move 10 meters per second instead of 10 meters per frame. So here you can see they have introduced the concept of time.delta time, and so each time you are in update. So here you gotta learn what is time.delta time. Again, time.delta time is frame rate independent. Frame rate independent. Again, this looks little bit advanced. So I will undo this, or I can show you how it will be played. So what will it do is, what transform means is that I will show you. So this is the component. Sorry, this is the component name tutorial player movement 1. Tutorial player movement. No, it's simple player movement. So let's uncheck this. That is remove component. So now this component is removed. So what it will do is transform dot translate, and this is translation. What translation was that every time the difference between two updates is known as time.delta time. To make you understand better, you can say that on mobile devices this update will be called 30 times. 30 times. So if you divide that by, let's say, 1000, so every update is being called, let's show you, 30 divided by 1000, 0.03. So every 0.03 millisecond times 0.03 millisecond time, this will be called. So again, by 0.06 millisecond times, this will be called. On system, on PC device. So what this means is that if we do computations here, that is the movement, so it won't be as uniform as it should be. Non-uniform if we do computations without time.delta time. So here time.delta time helps us by giving the frame rate hence I will write it here again. Time.delta time is frame rate independent. Why this update method does not have a way to be frame rate independent. So every time this unity does this for us is that through this way, this uniform way, time.delta time. So what this means is if you press the key in mobile device or on a system, our player would move in a similar way. That is, if you want to jump from one building to another. So if we press a key one time, instead of being slow on slow devices, the computation side we won't be error sum at all. Instead, a uniform things will be given. Again, just to check you here, you can head over to docs.unity3d.com, press scripting API, and then press time.delta time here. And this is what does show. And here you can see the much better description. The time.delta time is the interval from the last frame to the current one, and hence this can be used better. So what this means is that, just to show you what it does, is transform dot rotate 0 degrees per second into time.delta time. So this will be rotated in a uniform way, that is, after each second certain angles would be passed of rotation, while through the other way we couldn't get a hand on the rotation. and that our rotation would be non-uniform. So to play this, what we gotta do is play. Again, script wasn't saved, so I will save the script again. I will save the script again and wait for the program to load. All right, so it is as you can see. Right now it's not moving neither through x-axis or y-axis, since I haven't pressed any key. But when I do press the key left and right, as you can see, it's moving up and down and left and right along the keys. This code I didn't wrote for myself. This I just copied and pasted from official Unity docs for the Input.GetAxis, and this is our result. So here the thing that you want to note for yourself is that time.deltaTime is the thing that made it much more uniform uh, by keeping note of how slow. This is something time.deltaTime is by default is given by us from Unity black box. So it has been designed in a way so it tells us that if the game has ran slow, that is on slow devices, time will automatically increase in a way that the ultimate result will not be affected. So I hope this is understandable for you. If you're still not sure, you can ask ChatGPT that how time.deltaTime makes the game much more uniform. How makes the game frame rate independent on logic side. So this will tell you so this is what it says. This was by default what we could have expected if there was no black box solution offered by Unity with the name time.deltaTime. What would happen is we would be getting different results on different computers on different platforms. Reason being is that there is different hardware and which doesn't takes note of being frame rates different, frame rate difference, and hence once one game would be slow and second game would be faster. But thanks to time.deltaTime, our game scales properly with time. So this is something that has to be kept in mind. And what was the final result? Final result was now we can move our character along z-axis and we can rotate around our y-axis. So if we zoom it out, as you can see, it is showing both behavior, that is standing and rotate, that is translation. This is translation up and down, and this is rotation. It is rotating along the world axis with pivot around somewhere here, and it is rotating. But right now, for our game sake, again we can adjust the speed here. Let's increase the speed to let's decrease the speed one time to 1, rotation speed to 10, let's say. And now when we move, our character will move very slowly. Again, this is something that you can do for yourself, and in the next tutorial we will be addressing how we can move it along an object on a bridge, And for doing that uniformly, what we can do. Again, I hope at this point I assume that you know that how you can use time.delta time, and this is time.delta time, and how it helps make games run consistently on different mobile devices, or makes it platform independent. Thank you. Let's head over to next.